Okay, so I want to show you folks a couple of these Arduino projects before we actually get into the class today. One of the problems you can have with students when we start talking about Arduinos is basically you sit there and you talk about all these amazing things that people can do with Arduinos, and folks get confused because they're like, what should I do? What should I build? And you're like, well, what do you want to build? What do you want to do? And then you get into one of those conversations with students. Oh, that whole thing about as a technology professional, you're supposed to use technology to solve problems, and a lot of times, I don't know, the whole creative thing, it can be a little bit difficult for some people when they get into the tech field. So I just want to show you a few of these little projects that you can do to start to get an idea of why Arduinos are cool. Because the thing with Arduino is you get to build whatever it is that you want to build. So if you really don't know what you want to build, well, that becomes a problem. So I have a couple of projects here I want to show you. So this is my little temperature sensor project. So basically with this temperature sensor project, I have an analog temperature sensor connected to my Arduino. When the temperature is below 80 degrees, the LED is green, so it shows you that the temperature is okay. When the temperature goes above 80 degrees though, the red LED comes on. It also triggers the relay to turn on, so the fan gets turned on. So think about this as an automatic, climate control system. You could have this connected to an air conditioner. You could have it connected to a dehumidifier, any type of thing like that. So if I put my little finger on here, what you'll see is in a second, hopefully, we'll get to 80 degrees. Come on now, you can do it. There we go, we got to 80 degrees. The red LED came on. Oops, the red LED came on, and the fan came on. Right? And so that's all happening automatically. So imagine if you put this in something like your server room, in case your air conditioner turns off for some reason, you can have an automatic fan system just to make sure that your server room stays at least relatively cool. Again, you could also connect all kinds of different electric devices to a relay like this and create all kinds of cool solutions. This is actually using a temperature sensor, or I'm sorry, a distance sensor. This uses a distance sensor. Let me turn this off. So. There we go. And what this distance sensor does is using ultrasonic, basically sound waves, it determines how far something is away from the sensor. And so what I've done here is we basically just kind of have like one of those backup beepers. You know when you're backing up your vehicle and it starts going beep, 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 right? That's the same type of thing I created for this type of project, just to kind of show you how this works. So if I turn this thing on, it starts beeping, and then when I put my hand closer, right? And then I pull my hand away. And so the speed of those beeps, right, is all, those are just simply variable values. So just like I turned on a fan over here with a temperature sensor, I could trigger that kind of thing with an ultrasonic distance sensor. So if somebody got too close, you could turn on a bright light to warn them that they're too close to like hitting a wall or something like that. You could use this for an obstacle avoiding vehicle, that type of thing. So that's one of the types of sensors you can do. And then one of the things that's really cool, but quirky. I will admit it's quirky. Hey, look, I give you folks ideas. I show you possibilities. I don't necessarily show you good code. If you want good code, I don't know, go watch New Boston. Anyways, what's really cool with this is actually an Arduino Uno with a full Wi-Fi stack. So this is a TCP/IP 4 Wi-Fi stack on it. So what we're able to do, I'm going to show you in a second, is you're able to connect to this. This actually gets its own IP address. You're able to connect to the IP address. From that IP address, you have a little web page that it's creating for you that gives you the basically controls for the vehicle, and then you can make this thing go forward, left, right, or backward simply by clicking on little hyperlinks on the web page that it's being presented. Now I'm going to show you this to you in a second. I want to warn you. It's quirky. It's quirky. There are better ways to do it, but I just want to give you an idea of what this thing can do. So with that, let's go over to the computer and I'll show you the little web page, and then after that we'll get into the class. So now we have my computer. We have my little Wi-Fi Arduino car. So what we're going to do is I'm going to plug the battery pack. So we plug the battery pack into my little Arduino car. We're going to shove it in here and we're going to turn it on. So the power is now on to this thing. And now what I'm going to do is I'm simply going to run over here. I'm going to put this little thing on the ground where you can see it. And then we're going to go here. We're going to see how much I can embarrass myself. Okay, so let me refresh. So the IP of this thing is 10.0.1.15. And you can see that it's moving. Stop. Okay, well, let's try to make it go forward. You want to try to make it go forward? Okay. Forward! Left! 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 Forward! Right! Forward! Stop! Backwards! Oops. Quirky. Left! Forward! Right! Forward! Stop! Oh, you can't really see it there. Okay, forward! There we go. Left! Forward! Right! Forward! So again, this is one of the projects that you can do with Arduinos. Though I will say that this one's a little bit quirky, but I'm just giving you concepts and ideas here. So give me a second. We're gonna jump into this class. So how y'all doing? How y'all doing out there and wherever the hell you are? So we're going to do an Arduino class today. We're going to do an introduction to Arduino class today. Are you excited? I hope you are. I hope you are. I hope I didn't waste my time creating this class. Again, when I do these classes nowadays, these are supposed to be the director's cut. Essentially, the idea is I do these presentations here at the Silicon Dojo in Asheville, North Carolina, to a live audience. And then afterwards, I get feedback from the audience, and the next day I come in and I record basically the same presentation with the things that I've learned from my audience the next day. Well, here's the thing. Apparently Arduino is not the most popular thing in the world for some reason, and so I got nobody showing up to my class last night. I was supposed to have 4 people here in Asheville isn't a bad audience. I knew 2 of them, I didn't know 2 of them. The 2 people that I knew, they got busy, so they weren't able to come. The 2 people that I didn't know, they just didn't come either. So, yeah. I have a whole slide deck. So you all are gonna get a class today. I don't know, this is one of those things to be thinking about if you are going to be creating your own Silicon Dojo. Sadly, some of the things that are what you consider the coolest things in technology, other people might not find that exciting. Again, I think Arduinos are awesome. I've been doing technology since from 1996. I have my MCSE, I have my military training. I've done all kinds of amazing stuff. And Arduinos are absolutely fabulous. These are great little things, and I think every modern technology professional should grasp how these things work. But the problem is that there's just not enough brand recognition around Arduino, right? If you talk about cybersecurity, if you talk about hacking, if you talk about bezels, you'll get people to come to your classes. Sometimes if you talk about things like Arduino, right? If people don't know what you're talking about, then they don't know to come, even if it is really cool. So this is just something to be thinking about for your Silicon Dojos if you're going to be trying to do this in your area. If you're trying to get people to come to your classes, remember clickbait. Clickbait isn't just for the internet, it's for the real world too. You know, I don't know. You might do like cyber security or like penetration testing using an Arduino, right? People want to know about penetration testing for some reason. And then you can kind of like shove the Arduino in there somehow. I don't know. Again, that's one of the things. I come here, I am trying to give you the real world of how the technology profession works. And again, clickbait. Clickbait is something that you gotta deal with wherever you're at. It's not just for Twitter anymore. But anyways, we're gonna do this introduction to Arduino class because I actually think it's a good class. I actually think Arduino is really cool. And I think everybody in modern technology should at least grasp how Arduinos work. You know, whether or not they know they should. So anywho, just so you know, basically when we're talking about the Arduino, again, I'm gonna talk about a lot of stuff in a few minutes, but just so you get an idea of how these little Arduino projects work. So this is that little temperature sensor project. This is basically what the code looks like. So you write all of the code in what's called the Arduino IDE. So you're generally not using VS Code or some other IDE. You're using the Arduino IDE, and it's a very simple coding language, supposedly based off of C++. I don't know. It's the language you use. Basically what you do up here is you define the pins. So I define the sensor pin, the red LED LED pin and the green LED pin. So I define environment variables up here. Then we do the setup. So this basically sets up the environment for the code to run in. So what I do is I start the serial monitor, and I start it at 9600 baud. I then set the pins that I created, the red LED and the green LED. Those are called digital pins. I set them to output. And then after that has been set up, what we do is we come down here and we actually just run through this loop. So this block of code right here takes the readings in from that analog temperature sensor, turns those readings into a value we care about, temperature Celsius, temperature Fahrenheit. It will then print out onto the serial monitor, I'll show you this later in the class, information. And then we have these little if else statements. So if temperature Fahrenheit is greater than 80, turn the red light off, the red LED off, and turn the green LED on. Else if the temperature Fahrenheit is greater or equal to 80, turn the red LED on, turn the green LED off. Else, so if something is entirely wonky in this code, I always put some kind of troubleshooting procedure in there. Digital right, so LED high, and this one LED low. So basically just try and put something in there in case there's any issues. I should actually change that. Probably change that to like both of them be high. That's what it should be. I messed up my code. Can you believe Eli, the computer guy, messed up a little bit of code? But anyways, so if it's not less than 80 and it's not greater than 80, then turn both LEDs on because you got some weird ass value coming in there. So anyways, then we come down here, we delay for 3 seconds, and then it continuously loops. This is a big thing to understand about with Arduinos, is Arduinos are not computers. They are what are called microcontrollers. And so with a microcontroller, all that's happening is a loop. It's not a normal operating system. So basically you give it the code, and it just keeps looping, right? It's a while forever loop, essentially. And you just keep looping, and it goes through, grabs a value for the temperature, prints it out, does the if, else, if, else statements. Waits for 3 seconds, goes through. And so that basically gives you an idea of what the code looks like for when we're dealing with the Arduino world. So with that, let's get in the presentation. Again, with these presentations, I have started doing my presentations here with Silicon Dojo with just some notes, talking about things like what Silicon Dojo is, if anybody had actually showed up. One of the big things is I was talking about the COVID policies. See, that's the thing. Right now, if you're watching this, topically in the time continuum or whatever, we're still trying to figure out what the hell to do with COVID. And so we didn't have any specific COVID policies for Asheville or Buncombe County, the county I'm here in North Carolina, when I did these notes yesterday. And so basically, I was explaining what the COVID policy was. The COVID policy was, I'm vaccinated, my wife's vaccinated, you do you. That's what the COVID policy was. Unfortunately, it's COVID, it's our government, things change. Apparently we are now getting the mask mandates again here in Asheville and Buncombe County. I'm also betting we're going to be getting lockdowns again sometime soon. And so one thing for me, for Silicon Dojo, is I am actually going to stop doing these seminars, at least the live seminars, for a while, because I'm not able to talk for 2 hours through a mask. This isn't a science thing, this isn't a politics thing. The way that I talk, the way that I communicate, the way that I vocalize when I have a mask on, it shreds my vocal cords to do that for an hour or two. I have no idea how public school teachers or professors do it. Golly bless them that they are able to do it. I am not. And so since Asheville and Buncombe County are now requiring masks for all indoor venues of any kind, I'm actually going to be shutting down the live seminars for a while. So again, an important thing to be thinking about if you're trying to create your own Silicon Dojo, you're doing these things, is basically how are you going to deal with the ever-changing world of COVID in the modern era. Again, my thing, looking at the science, actually listening to people. I think we're going to have COVID until at least 2024. I'm not being snarky about that. I'm not being bombastic about that. If you realize that Africa has had very few vaccinations at this point, if you realize we now have the Lambda variant that just came out of Peru. Oh, God. Yeah. Anyways, COVID's going to be around for a little while, one way or the other. So, again, for your own dojo, your own educational environment, you need to figure out what the hell your COVID policy is. I'm not telling you what you should have as a policy, but you do need to be having one. That's where I'm excited. You may notice I am now in a new office space. Literally last week, because this is how the government works. Literally last week, I was able to move into this new space. This is 500 to 600 square feet. It is big enough for me to do labs and all that kind of stuff. I was really excited about the future of Silicon Dojo. And then we get the mask mandates and everything. Anyways, that's how it goes. One of the things I'm going to be starting here at the dojo, again, one of the real core components that I want for the dojo is the open labs. So those are actually going to be coming here in like a week or two. I just have to work out a couple logistics things with that. And with that, people will be able to come in, they'll be able to build Arduino projects, they'll be able to build Linux servers, they'll be able to build stuff with Raspberry Pi, the whole 9 yards. And I can do that with a mask on because I'm not communicating that much. It's like, okay, here's the IDE. Okay, click this, click this, click this. Right? It's not doing a seminar. So we are going to be doing open labs soon here. And so again, this is something that you need to be thinking about if you're creating your own educational environment. Is again, within the real world environment that you have, what can you do? Don't worry so much about what can't you do. Right? You have all these things, all these possibilities. And then based off of your environment, you decide what you're actually able to do, right? So I'm in the United States. I have some money to be able to fund all these things. I have decent internet connection now, right? So there are things that I can do. I can have an office space. I can have decent internet connection. I can have equipment so people can come in and work on things. But because of the COVID mandates, I can't sit here and do seminars anymore. So it's like, okay, I can't do seminars, but these are all the other things that I can do. Again, in your environment, maybe you don't have all these gadgets. Maybe you don't have a lot of the resources that I do, but you don't have COVID mandates. Well, then you can do presentations. You can do seminars, right? Again, one of the big things I want you folks to always be thinking about, don't hyper-focus on what you can't do. Figure out what you have the resources and ability to do, and then do that. The goal is to move the ball down the field. If you only move the ball down the field an inch a day, that's still an inch. That's still an inch, right? I don't know football. A lot of inches and you'll get a yard. Even more inches, you get first down. I don't know, you just keep pushing that ball forward and at some point you'll get first down. Whatever the hell that actually means, right? So again, something to be thinking about if you're gonna be creating your own dojo environments. So with that, let's get into the Arduino introduction. So again, I am actually really excited about Arduino. I love Arduino. Arduino is amazeballs. I think this is really exciting, and I think this is a great thing, especially when you start thinking about IoT. The problem that I see is, again, I don't think there's enough brand recognition with it. Again, people know about smartphone apps. People know about iOS. Arduino, again, they've kind of heard about it, but they don't really understand why it's important. So hopefully going along today, I'll explain to you why this is really cool. And I think Arduinos are really cool from an educational standpoint because it can teach you a lot about the core concepts of technology. So you learn how to code, right? In that C, C++, whatever the hell language it supposedly is, right? You're learning else-if statements, you're learning loops, you're learning conditionals, you're learning variables, you're learning about setting up your coding environment. Like that's all the same kind of stuff you do, whether you're doing Arduino or Python or I don't know, React Native or something like that, right? It's all the basic, core concepts there. Again, adding inputs, adding sensors as inputs, processing the values that come in from those inputs, and then outputting to something. Do you output to a screen? Do you output to a buzzer? Do you output to an LED? Do you output to an SMS message using Twilio? All of those things are available for you. And so I think Arduinos are a very good little educational tool because it teaches you all of this stuff. And the nice part is, you don't have to worry about Microsoft bugs. You ever, when you're learning Microsoft and you're sitting there learning Active Directory or something, and then your server just blue screens to death for some reason? And you're like, why? That's one of the nice things with Arduinos. The great thing about Arduino is Arduino just does what it does. Now, it doesn't do a lot. You're not going to get a word processor in Arduino. You're not going to set up an email server in Arduino. It doesn't do everything under the sun. It just does what it does. But it does what it does, and it always does what it does. So when you're teaching people using Arduinos, you don't have to worry about, blue screens of death, all that kind of stuff. And I really think they're cool. I swear. So when we talk about an Arduino, the important thing to understand when we're dealing with Arduinos is these are not computers. So a lot of times people think Arduinos and Raspberry Pis are the same thing, right? You'll hear Arduino and Raspberry Pi in the same sentence, so a lot of people feel same, but a little different, right? No, not same. Damn near nothing to do with each other. The main reason people think that Arduinos and Raspberry Pis are the same is basically what's called GPIO pins. So these pins, so I have digital and analog pins on the Arduinos, right? You also have those on Raspberry Pis, and so these are what allow you to connect to sensors. These are what allow you to connect to LEDs, the whole 9 yards. Our Arduinos have GPIO pins. Raspberry Pis have GPIO pins. That doesn't mean an Arduino has anything to do with a Raspberry Pi. Entirely different world. A Raspberry Pi actually has a Linux, most likely operating system on it. You can install a full lamp stack. You can basically do everything you can do on a normal Linux server on a Raspberry Pi, it just has fewer hardware resources. An Arduino, it's a microcontroller. So basically what the microcontroller does is, like I say, so how this works is it just continuously loops through the code. It gets readings in from the different pins for the microcontroller. It figures out what should happen based off of what's coming in, and then it sends some kind of output out, right? So with this, again, you're not dealing with Linux, you're not dealing with Windows, you're not dealing with Mac OS, you're not dealing with ports, you're not dealing with the normal things you would deal with a computer because it's a microcontroller. Basically, it's a whole bunch of transistors that are all together. The actual microcontroller is this black thing right here. Basically, a lot of transistors, a lot of if-else statements in there, essentially on and off. And that gets you, getting your LED turned on, that type of thing. And again, like I say, with the code, all that happens is it continuously loops, continuously loops. That's one of the problems you can have when you're coding for Arduino. One of the problems you can have when you code for a normal computer is you can accidentally loop something in the code, so it continuously loops and then burns up all of your resources. You can run into memory leaks or other kinds of issues if you have just continuous loop in your code for some reason. You actually have the opposite problem with an Arduino. Since this is continuously looping, if you have some line of code that for some reason stops the code, stops the loop, right? Wait for something, until something happens, don't continue. Well, then if it never gets that signal from something, it will just kind of stop there forever. It will not do anything else. So loop, 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 loop. Now, when we talk about Arduino, one of the things that comes up is Arduino is actually considered a development or a prototype platform. So that's one of the things that people get a little confused when we start dealing with Arduinos, is basically the idea of what is the Arduino itself. Is the Arduino a tool for you to design other electronics products? Or is an Arduino an actual component that you can use in your electronics product? And the answer is basically yes for both of those. So the idea with the Arduino is, when the folks in Italy were coming up with this idea, is they wanted to have some kind of board that made it a lot easier to understand electronics. So basically make learning electronics and learning coding a lot easier. So back then you couldn't buy an Arduino because the Arduino hadn't existed yet, but you could buy a microcontroller, and you could buy all of these, the power source, the power regulator, USB connectors, all that kind of stuff. And so the thing was, back, however many years ago, if you wanted to create your own little electronic device, you had to go out and you had to buy the IC, the integrated circuit chip. You had to go out and you had to figure out how to do the power regulation. You had to go out and you had to solder everything together. And that was a big barrier to entry to a lot of folks. And so what the Arduino people decided is hey, let's create a minimum development board that gives everybody the basics of what they need to create electronics projects. So we'll give them the IC chip, we'll install that, we'll install a power regulation system, so you can just plug this into a wall or you can power it somehow. We'll break off all the digital pins pins and the analog pins, so you don't have to solder. You can just use little wires to connect to them. And then basically we'll give this to people so that they can then very easily prototype and design products, and then once they've designed those products using Arduino, they can then ship off the schematics to some kind of PCB manufacturing company, and that PCB manufacturing company would then actually build the electronic project that they had created with only the components that they need, right? So if you only need 3 digital pins, and you only need a couple of other things, instead of having this whole board, what would happen is you would ship off the schematics to a PCB manufacturer. They would then just manufacture the little tiny device that you created, and then you get back just a little tiny device, something like this size instead of this size. That was the original idea with these things. And so that's where, when you hear about it being called a development platform, that was the concept there. The thing is, the clones, the Arduino clones, have become so inexpensive that a lot of times it actually makes sense just to build your electronic projects simply off of the Arduino boards themselves. So with Arduino is an open source project. So basically anybody can design these boards. They can build the boards, they can sell them, they can call them Arduino the whole 9 yards. It's not piracy, it's not intellectual property violation. That's actually something that the Arduino folks want, right? The Arduino folks create their Arduino boards, and then everybody else creates their version of the Arduino board, and it's all completely legit because it's an open source project. Well, the thing is, if you go out and you buy an actual Arduino board, so this is an Arduino Uno board, this is going to cost you about $40. Now, to be clear, it's Italian engineering. You know it's good quality. It really is. So for the school, all the Arduino boards basically that we use for class are actual Arduino boards. We have Arduino Uno boards, we have Arduino Uno with Wi-Fi boards, we have other Arduino boards that come from Italy because these are designed and these are built incredibly well. It's good standard products, it's high quality products. So if I put this in front of a student, they're going to be able to build their project, and I'm not going to have to worry about there being some weird little quirk with a particular board. Again, something to be thinking about when you buy a product is what you're going to be using it for. It's going to be difficult enough teaching my students how to build things with Arduino before you add in, problems from the manufacturing process, right? So anyways, these cost about $40. So again, that's kind of pricey. I don't know. But the thing is, if you go with clone boards, so this is from a DF Robot clone board. I have a Sane Smart clone board. There's all kinds of stuff. Yeah, there's a Sane Smart clone board. All right, these are just different clone boards. They're basically more or less the same. Just got some different things with them. The thing is, with the clone boards, you can actually get these down to $6 or $7 a piece. Right. So again, from a price point, building a $40 board into your project, that might be a little expensive, especially if you're doing 10 or 100 or 1,000 of these devices. At $40 a pop, that's kind of pricey. I don't know, $7 a pop? I can just buy this for $7. I can add my components. I can ship it out the door. At that price point, it actually starts to make a lot more sense to design your project simply using the Arduino boards or the clone Arduino boards, and then shipping the product out the door that way. So those are some of the things to be thinking about with the Arduino. Again, basically it's a development platform. The idea was you're supposed to design your product, then you were supposed to ship it to a manufacturer. The manufacturer is going to actually manufacture something for you, but the price of the clone boards have come down to such a degree, you might just want to build your projects directly off of the clone boards. We go over a bit again when we start talking about all the things that are built into an Arduino board as a development board. Again, they give you the USB connector. There's a USB interface chip, so that USB can actually connect to this thing, communicate with everything. A crystal oscillator for the timekeeping, voltage regulator. You have the power port they give you. You have analog pins. This is the microcontroller itself. You have little LEDs on here for give you little troubleshooting things, and then you have the digital pins. So basically, again, what they do is they've taken all these components, they've soldered it to a board, and then they give you this finished product. When you're going out there and you are looking for boards, a big thing to understand is there's a crap ton of these boards. So many boards. These are only a few of the boards, right? Just Arduino. This is an Arduino Uno with Wi-Fi. This is an Arduino. This is an Arduino Mega. Where's my Arduino? This is an Arduino Nano. So these are actually just Arduino boards. And so one of the things to understand with this is, you know, they're same, but different, depending on what project you're trying to do, depending on what you're trying to accomplish. You may want to use different ones of these boards. So the Mega Board, the big thing with the Mega Board is it has a crap ton of digital pins on this. So if you need to connect a lot of sensors, a lot of output devices, you might want a Mega. This is a Nano board, so it's very small, it's very lightweight. So if you're doing something, let's say like a little aerial vehicle or something like that, you might want to use a Nano. This is an Arduino Uno with Wi-Fi, so this comes with a full Wi-Fi stack on it. There's different things when you buy these. So what I would recommend for you folks out there is basically you buy just like the standard Arduino Uno, and then you learn how everything works and go from there, because there's just a lot of this. We go over. Let me just get out of this for a second. We come over and we take a look at this web page here. Basically, we can see like there's all kinds of different stuff. So this is the Arduino Zero here, the little Nano I was showing you. And if you go to down here, it'll give you all of the tech specs. So basically, this is an important thing depending on the project that you're doing. It tells you the power supply, 5 volt. Gives you the current. So again, since you're dealing with sensors, you're dealing with inputs and outputs and that type of thing, you actually have to know a little bit of electronics. So DC current for 3.3 volt pin is at 600 milliamps. Gives you what the circuit voltage is. It gives you how many digital pins you have. PWM pins is something called pulse width modulation. We'll get into that in a bit. And basically it gives you a whole bunch of all of this information. And you go through and you decide whether or not this board does what you need it to do. Oh, if you go over here, this is the Arduino Uno Rev 3. Oh, this is down to $23. I thought they were more expensive. I don't know. Anyway, so this is $23. Maybe that's more your speed. Again, we come down here to tech specs. It gives you what the microcontroller is, the operating voltage, the input voltage, so 7 to 12 volts if you're going to be powering this thing. What the limit is, so 6 to 20 volts. So if you give it less than 6 volts, it will not work. If you give it more than 20 volts, you'll burn the darn thing out. Something good to know. How many digital pins it has. Current per I/O pin, so it actually sends out energy, electricity, over those I/O pins. So that does 20 milliamps there. Tells you how much flash memory it has, clock speed, a few other things, right? We go up and we take a look at the Uno Wi-Fi Rev 2. Okay, so that's $45 there. We go and we take a look at the tech specs, and again, you can come through and you can see all these different tech specs, and based off of what you're trying to do for your project, you'll decide which exact board you will need. But this is an important thing. Again, with the Arduinos, I feel like the Arduino they have too many products. It's kind of like, this is one of the problems you get to with a lot of companies, where instead of just building like one thing that does like what everybody needs or most of what everybody needs, a lot of times they come out with 30 different products, and then the big problem comes for the consumer is you're not really sure which product to buy. You're like, I need this, but I don't need this. Oh, maybe that one will work or this one will work. And then all of a sudden you buy. Basically, they try to create the most specific product, but what really happens is you end up having to buy 5 products in order to figure out the one product that you actually need. So this can be a real pain in the butt. So something to think about. Okay. Oops. There we go. Then we go over, like I say, with the clone boards. If you're looking to buy a clone board instead of an official Arduino board, I pulled this up literally yesterday for this. This actually has a Wi-Fi stack on it. The ESP8266 is a full TCP/IP4 Wi-Fi stack, and you can see you can buy this as of yesterday on Amazon for $7. So again, as you just saw, this Arduino Uno with Wi-Fi is $44. You can buy a clone for $7. Now, the important thing to understand, because I know some of my viewers, Arduino's trying to rip you off. See, that's the problem with those kind of companies. They just think they can charge you any amount of money and rip you off. Here's the thing. I've got clones. I've got a pile of clones. I also have a pile of real Arduino boards. And here's what I'm going to tell you, is the manufacturing and the quality control of the real Arduino boards is just so much better than most of the clone boards out there. Again, it's hard to show you really when you take a look at these clone boards, but it's simple things like where all the I/O pins are. So there's something called a shield. We'll talk about this in a bit, but basically a shield, think of this as kind of like an add-on card for the Arduinos, and the shields have these little pins at the bottom, right? They've got these pins. And so if you have an official Arduino board, generally, of course this one has pins knocked out of the way, generally with an official Arduino board, it is relatively easy just to slot everything together. Of course, I pick up the one shield that has bent pins. Anyway, how about a different shield? Crap, that has bent pins too. You're killing me here. Anyways, okay, so this one doesn't have bent pins. There we go. All right, pretend this goes together. And then it's so easy to get it together. Anyway, I'm such a horrible teacher sometimes. Anyway, right, there's pins on the bottom of these. So if the pins aren't bent, and you take a real Arduino board, you can slot these things together generally a whole lot easier. What I was trying to show is when you use a clone board, many times the pins, they're kind of out of whack a little bit, and so when you try to slot the shield onto the boards where the pins are out of whack a little bit, it's much harder to do. Of course there, it was just easy. Anyway. I swear to you, the clone boards are not built as well as the normal Arduino boards. Oh, can I go home now? Can I go home? Ooh. So anyways, things to think about whether you go with Arduino or clone. Again, the big thing with the clone boards is these are not pirated things. They're not illegal or anything like that. It's all open source, so they're completely allowed to do it. Now, when you're dealing with the Arduinos, you're going to see something as far as memory is concerned. So you'll see flash memory, you'll see SRAM, and you'll see EEPROM. The big memory that you're going to have to worry about is the flash memory. This is for program space. Basically, this is where your sketch is stored. So that code that I showed you previously in the Arduino world, that is called a sketch. So what happens is you will upload that sketch to your Arduino, and there has to be enough storage on the Arduino in Flash to actually be able to upload that sketch. Here's the thing, when you're dealing with, especially with Arduino Unos, there is very little flash memory on this thing. I have created many, what I considered relatively simple projects that basically they required more storage than what the Arduino Uno had to offer. And so many times, actually, I use an Arduino Uno with Wi-Fi because it has more flash storage. And again, we're talking about flash storage. We are not talking about a lot. Again, these are not computers here. These are microcontrollers. So as far as the flash storage on the Wi-Fi, so this is the Arduino Uno with Wi-Fi, that has 48 kilobytes. 48 kilobytes. Now if you go over and you take a look at the Arduino and you look at its flash storage, it only has 32 kilobytes. K. I'm not stuttering with that one, that's a real thing. So basically with these things, they have very little storage for actually uploading sketches. And so one of the problems you can run into is when you start creating more complicated sketches, when you start using more libraries for different types of digital devices, you can run into an issue of there might not be enough storage on the Arduino that you're using, and so you may have to use a different Arduino. So I was actually doing a GPS project a little while ago. So this is a GPS module that you can add to an Arduino. Basically created this whole project, and it kept failing because I was literally unable to upload it to an Arduino Uno because it did not have enough storage. All I did was put the exact same thing onto the Arduino Uno with Wi-Fi that had 48 kilobytes of storage, and so that actually had enough storage so I could do my particular project. So this is going to be one of those things, the larger project, the more complicated the projects you do, you may start running into a storage issue with that flash storage. Just one of those things to keep in mind. And again, this is the type of thing where I think it's kind of valuable for something like why I want to do something like Silicon Dojo is because many times one of the big issues is that people don't know what board to buy. They don't know what board they need to use, right? They want to create a project. It's like, oh, I want to create a project that uses a GPS system to, I don't know, store data to an SD card, right? They know they want to do that. But the problem that they run into is they're not sure which Arduino board to build that off of. And so the problem is if you're alone at home, then you keep buying Arduino boards until you find one that works for you. That's a lot of waste. Again, one of the key concepts here for Silicon Dojo is that I've got all these boards here, right? If you want to build a project, you just come in, you use any of the 50 boards that we have, you see what board works for your particular project, and then you go home and you buy that particular board, right? Basically the idea is you see if it works. Does the project work at all? What products do you need for the project? Tweak all of that, design whatever you need to design, and then you go home and you buy your actual components. I think that's one of the sales pitches I have for Silicon Dojo, and just something to be thinking about with this kind of thing. Is again, there are just so many components, so many modules, so many shields, just so much stuff. And so if you can share all of those components with other people, it makes it better. When you're looking at the Arduino, again, I've talked about the Arduino pins here. And so basically over here you have what are called the digital pins. Down here you have the analog pins. Here you have power, so you have 3.3 volt pin here, you have 5 volt pin here, you have ground pins. Then you have something called I2C, SCL, and SDA. This is actually really cool. I2C is an electronic communication protocol. It's actually an addressable protocol where you can add, it's like 126 devices to your electronics project. So this is an I2C screen. All you do is you connect a couple of wires from this I2C screen to your Arduino. You write some code, and then basically it communicates at the address. It's an address, kind of. It's not an IP address, but you know how TCP/IP is an addressable protocol. Each device on the network, each host on the network has its own IP address. Basically, it's sort of the same with I2C. Each component on the electronic device has its own address, and so the device is able to communicate with those different things on it using that address. So that's something. They have the SCL and SDA pins here, and then you have something called ICSP pins that are down here. These pins are generally used down here for programming the Arduino in the non-traditional way. So normally, when you're programming the Arduino, you actually just simply plug it into to your USB connector. You open up the IDE and you install the sketch that way. There are other ways to actually load that sketch onto an Arduino, and you can use the ICSP pins in order to make that happen. When you're looking at the things that you can add to an Arduino, basically you have what are called modules and shields. So when we're talking about shields are the things you normally hear about with Arduinos, and they're really cool, but they may not be what you actually end up using at the end of the day. Essentially what a shield is it's an add-on card for your Arduino. So this is an Ethernet shield. So basically I can add this to my Arduino card, and it will give me an actual TCP/IP4 hardwired Ethernet connection so that I can have this either communicating with servers or being communicated with servers using that hardwired connection. It also gives me what's called a data logging module. So this allows me to plug in a micro SD card so that it can store data there somehow and actually read from it. And so if I wanted to make my device able to connect it to a hardwired network, I would use the network shield. If I wanted to connect to just be able to store data, right, we have what are called data logging modules. So this is a data logging module. This can take a full SD card, or it can take a micro SD card. This one can take an SD card, and this one actually has a real-time clock, right? So if I just need to be able to record values to a micro SD card and SD card, I would use this. If I want a clock component, because remember this isn't a computer, this doesn't have things like clocks built into it. So if I want some kind of time component, this is a real-time clock. I can set the real-time clock. It has a battery, so it always keeps the time. And then if I'm going to be storing values to a micro SD card, I can store the value along with a time code, and that's on that particular shield. And I mean, there's all kinds of stuff. If you want to be able to control motors, this thing will control motors. you're gonna add a whole bunch of different things with the shields. But the shields, basically these go on, you know, like an expansion card. The big thing to understand, a couple of big things to understand when you're dealing with the shields, is whenever you're using a shield, the shield is actually using specific pins on your board, and they are no longer usable by anything else that you're going to be connecting to this project, right? So if I connect this particular data logging shield onto my Arduino, it may use digital pins 8 and 9. So basically using digital pins 8 and 9, you'll be able to communicate with the micro SD card or the SD card. But because you're using digital pins 8 or 9 for this shield, if you plug something else into digital pin 8 and 9 on top of this, you may run into problems, right? So this can be a big issue too if you start stacking cards. So you can stack cards, right? You just keep adding them up onto to one of these Arduinos. One of the problems though is if two cards are basically trying to use the same digital pins, you can run into issues. The other thing you can run into that's very weird is just because cards seem the same doesn't really mean that they are. So this is a data logging shield, and this is a data logging shield. This data logging shield has ICSP connections. This data logging shield does not. For one of the projects that I was using, I had to have a data logging shield that used an ICSP connection. So again, it was like, oh, I need a data logging shield for this project, so I ordered a data logging shield. But this data logging shield didn't work. It's like, crap, why doesn't this work? Oh, I looked, I need ICSP pins. So when I got the ICSP pins, these things, plugged it into the card, then my little data logging module project worked for me properly. And that's one of the things to realize is just because devices seem like they do the same thing, they may do it in a different way, and so it may be more or less compatible with your project. So these are all things that you can use for data logging. So this is a specific type of data logging shield. This is a data logging shield, and this is what's called a data logging module. You can put a micro SD card into this, and basically you run the wires from the back of this to your Arduino card. Well, here's the thing. For different projects, this works wonderfully. For other projects, this will not work at all, and I use this. For other projects, neither of these will work, and I need this one. Depending on what's required for the project, the different libraries are using, the whole 9 yards. Basically, even though these technically, at the end of the day, seem like they do the same thing, because they do it in different ways, they may or may not be compatible with your specific project. Something to consider. So anyways, these are shields. Then we get to modules. And so basically when we're talking about modules, these are any of the devices that you will be connecting to your project, and basically you wire the pins on the module to your Arduino card, and that's how you build the project, right? So this is a GPS module. This is a data logging module. This is an ultrasonic distance sensor module. This is a camera module. This is an Arducam, right? This is a real-time clock. If you want a clock, that's a clock module. This is something called an ESP8266. This is actually a Wi-Fi module. Here's an IR sensor module. Here's a DHT11. This is a temperature and humidity sensor module. These are communication modules. This is a PIR sensor module. So basically, any of these devices that you're going to be connecting to the Arduino board, these are going to be called modules. So shields actually slide on to the Arduino board. Modules are any of the plethora of other devices that you're going to be connecting to your project. When you're dealing with communication, so the input-output communication on those GPIO pins, basically the way you communicate with these different things, is either through analog communication, digital communication, or I2C. So, what we're talking about this. So some modules or sensors use analog communication. Basically with analog communication, what's going to be happening is you're going to be getting back, how to explain it, analog readings. So more or less, you're just going to be sending in and out things like voltages. So when you use the analog temperature sensor that I have for this particular project, there's a voltage that comes through, and then basically based off of that voltage, you do this whole little math equation in order to figure out what the Fahrenheit temperature is or the Celsius temperature is. So using analog sensors or widgets on your Arduino is relatively easy. Basically, you just have to figure out what value basically to be sending to that device, or how to process what you're receiving from that analog device. You run that through some math and it gives you the value. So if we take a look, like say here, yeah. So basically here what we have is int reading. So this is a variable called reading. You're going to do analog read the sensor pin. So it's going to do an analog read of the sensor pin, and then basically the voltage coming in will be reading times 5. Then voltage is going to divide and be equal to 1024. So basically reading is going to be multiplied by 5, then it's going to be divided by 1024, and then that is going to be the value for voltage. That gives you the voltage coming in. And then temperature C is going to be voltage minus 0.5 times 100, and that's going to give you the temperature C. And then for temperature F, you're going to have temperature C times 9 divided by 5 plus 32, and that gives you temperature Fahrenheit, right? So basically you have this basic value coming in over an analog temperature sensor, or some other kind of analog sensor. You send it through the math, and it gives you back a value that you can do something with. Relatively simple. Then you're going to get to digital. So basically the digital modules are things such as this DHT11. So this is a digital temperature model. So this gives you the temperature, it gives you the humidity, gives you some other things. In order to be able to pull out all of those values, it actually does digital communication. I should probably do a class on basic electronics, but it's a different way for these little devices to be able to communicate. The important thing to understand with digital communication is that you actually need a library in order to be able to pull the values or be able to communicate with the digital devices. So when we go and we take a look at code, basically you add a library at the top of your code and you say, okay, in order to be able to understand what this is giving me, go to this library, pull out the information from there, and then be able to process and be able to figure out what's going on. The big thing with any kind of digital device on your Arduino project is you need one of those libraries, and you can kind of think of it as like a device driver in the Windows world, where if you have a device driver, right, your hardware works in the Windows world. If you don't have the device driver, the hardware doesn't work, or it's quirky as hell. The same thing is true with libraries. So one of the problems you can get, especially when you get clone stuff, right, so when you get something from the Arduino manufacturers or some kind of non-standardized components, many times they have their own specialized libraries that allow you to be able to interact with whatever it is that you bought from them. And so sometimes you have to figure out where to download that from and actually be able to use that. I think about that with my GPS unit. Somewhere. Oh, you ever have one of those days? This is one of those days. Did I drop it? Oh, this is becoming a comedy of errors right here. Anyways, I have a GPS unit. I swear. Oh, there we go. There's my GPS unit. Perfect example is this GPS unit, right? So this GPS unit is a digital module that gets added to your Arduino board. In order to have this work properly, you need to actually be able to install a library into your code so that you can interact with it. One of the things that I found was originally the library that I was told to use with this GPS module just didn't work, right? Again, you think about the Windows world, you're told to download a specific driver, you download a specific driver, nothing works. Same thing can be true with libraries, right? So there are numerous different libraries out there for some of these different devices, and I think I ended up using something called the Tiny GPS library, and when I use the Tiny GPS library, I got this little module working in like 5 minutes. When I was trying to use the other library, it's like 5 hours and it still wasn't doing whatever the hell it was supposed to do. And so that's one of the things with any kind of digital device is you're going to need that library. And something to be thinking about is sometimes, maybe the problem you're having is that the library you're using isn't doing what you need it to do. I think about that with the real-time clock. So the real-time clock, right? So basically all this is a clock. Oh, golly. Anyways. all this is a clock, right? So basically it tells you the time, it tells you the date, the whole 9 yards. It has a battery on it. It's supposed to have a battery on it, so even if the device loses power, it continuously figures out what time and date it is. One of the things I found with this is, again, this standard real-time clock library to deal with this thing sucks. Sucks. Pain in the butt. I'm not saying it doesn't work. I'm just saying it's a pain in the butt to use. And so one of the things that I found was that there is a much easier library to use, since I didn't need everything. Basically for me, when I was doing the projects, all I needed was the basic time, the time and date function. I didn't need a lot of the other things this thing can do. And so I found a different library that basically allowed me to set the time and read the time. That's all I needed to do. And so that was the library that I used for the real-time clock. So that's something to be thinking about when you're using these little digital modules. And then finally there's I2C Communication, which is absolutely awesome, especially if you're dealing with screens, right? So LCD screens, these are great for Arduino devices. Basically you can print out on the screen, you know, whatever information you want to print out on the screen, what the IP address is, what the temperature reading is, all kinds of different stuff you can print out on the screen. Well, here's the thing. If you use the normal LCD screen, the non-I2C LCD screen that you can go out and buy, it has a lot of pins to it. 10 pins? It has like 10. It has so many pins. It has so many pins on the back, and you have to connect every single one of those to the Arduino board, and it really sucks. And if you get any of them wrong, it's not going to work right. Really a pain in the butt. The nice part about this is basically you connect 4 pins. You connect your voltage, you connect your ground, you connect your SCL, you connect your SDA, and then you write your code and it works. Basically using the I2C protocol, you're able to communicate with this screen, and then you just print out everything on the screen, and it is very easy to do. So there are a lot of modules in the Arduino world that can use the I2C protocol, and so this is something that you might consider. Some of the higher end sensors, so like this sensor right here, right? I mean, this is a $1 sensor. It's a DHT11. I don't know, it might not even be $1, maybe it's a 50-cent sensor. Here's the thing, when your sensors cost $1, it might not be the most accurate things in the world. You know, you kind of get what you pay for. Many times you get what you pay for. You pay $1 for something, you're gonna get $1 worth out of it. And so for a lot of like the sensors that you're gonna be getting for Arduino projects, you know, horseshoes and hand grenades, accuracy. The thing is, if you're going to be doing more complicated projects, or if you're going to be doing projects where precision is really required, then you're going to need higher level, higher quality sensors that may cost a lot more money, and those sensors many times will use the I2C protocol instead of something like just the digital connections. So for like a temperature sensor, like this costs $1. So an analog temperature sensor, so this analog temperature sensor costs like 10 cents. This DHT11 costs like $1. And then if you want actually, you know, a temperature sensor that you could actually make a bet on, that's probably going to cost about $30, right? The reason is because it's actually going to be accurate. And so a lot of those use the I2C protocol. So basically, when you're creating your project, just good to realize these are different ways that these little things can communicate with your Arduino, and then, you know, build your project from that. Let's see, past that, controlling motors, right? So let's say you want to create a little project that allows you to like move a vehicle around, turn on pumps, you know, basically anything with motors. There's a couple of ways to deal with that. The first one is relays, right? So that initial project that I showed you where I turn the fan on and I turn the fan off, that is what is called a relay. Basically think of it as an electronic switch, right? So you have the power coming in on one side, you have the device on the other, so a fan, a water pump, a dehumidifier, whatever else on the other, and then you just have your digital pins connected to a little switch, basically a little on-off switch on the relay. And if you tell the switch to turn on, so basically if you send power to that little on-off switch on the relay, then the relay turns on, the power flows through, and then if you stop that little 5-volt electricity going to it, then the power turns off, and so the fan or whatever else device turns off. So this can be very useful for many things. Again, if you're going to be turning on a fan, a water pump, something where you are not going to need to adjust the speed. It's either on or it's off, and that's it. And you don't want to be clicking the thing on, off, on, off, on, off, on, off, because something is going to burn out, right? So that's what a relay is. Basically, it's just an electronic switch. Then you have something called an H bridge.
So this is an H bridge. So this is what you might see in a lot of like Arduino or Raspberry Pi type vehicles. And basically what an H bridge allows you to do is it allows you to connect an outside power source. So you can, like with this one, you can connect a power source of up to 30 volts to this. You can then connect your motors, and then you can connect this to your Arduino, and then the Arduino can then basically tell the motors to turn on or off, and using something called PWM, pulse width modulation, it can then change the speed of the motors. So basically that whole on-off thing I was telling you not to do with a relay, with a relay it's either on or off. Don't flip it back and forth, it's gonna be bad. With pulse width modulation, it's actually built to turn something on and off really quick. And basically that's how you speed up a motor or slow down a motor using this H bridge. So what happens with PWM is if you want the motor to be at full speed, you just have it on 100% of the time. If you want it to be at half speed, basically you have it on half the time and off half the time. So on, off, on, off, on, off, on, off, on, off, on, off, on, right? So it's on is right? On is and then maybe if you want it even slower, it might be off, 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 on, off, 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 on, off, 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 on, off, off, and that's basically pulse width modulation. And so you can use an H bridge to do that. So you have additional external power source coming to this H bridge that is then powering your motors. Your Arduino using PWM can then change the speed of how fast those motors are going. It is important to know with the Arduino that only certain pins are able to do PWM. I don't know if I can show this. I don't know if this will zoom in properly. Will it zoom in properly today? Come on, there we go. Oh, there we go. So you see the squiggle lines? So anything with a squiggle line allows you to do PWM. So that allows you to do pulse width modulation. If it doesn't have a squiggle line, you can't do pulse width modulation. That'll be something that I'll have to show you folks in a different, more advanced class, but it's just important to realize that it's there. And so that's basically the idea of how you're able to control motors. Then we have network connectivity. So there's a lot of ways you can connect your little Arduino project to the TCP/IP network. Again, so you can have your Arduino project literally sending out posts. So if you want to send values to a server and have those servers record the values, you can actually do a post to the server. In order to do something like that, you either have an Arduino Uno with Wi-Fi. So this is an Arduino Uno with Wi-Fi. This is a full TCP/IP stack that is actually built into it. Or you use something like the Ethernet shield. So this is an Ethernet shield. So basically this allows you to connect a hardwired network connection to your Arduino device. Or you use what's called an ESP8266. So basically this is like a Wi-Fi module, or you use a Wi-Fi shield. I also had a Wi-Fi shield somewhere around here. Oh, this is a wireless shield. So this is a wireless shield. This is actually a shield that you can add to your Arduino project to give it wireless connectivity if it doesn't already have it built in. So with those things, you're actually able to give your Arduino projects TCP/IP. And again, with that TCP/IP, you can send commands to your Arduino project. So if I know what the IP address is, like what I was showing you with this, right? So basically this little Arduino project is able to present a basic web page to me, and then with that basic web page, I'm able to click on different links and then have this vehicle move different ways. Basically, with that same thinking, again, you can turn on lights, you can turn on pumps, you can make other things happen. On the same hand, again, with post, you can have a device pulling in temperature values, pulling in other kind of values, and then based off of the if-else conditionals, it could then send that information up to a server and have that server process that information for you in whatever way that you want. Now, beyond TCP/IP and normal network connectivity, there are other ways that your Arduino can communicate. So again, TCP/IP. One of the interesting things is you can actually do serial communication. If you go over to my main website, elithecomputerguy.com, I don't know, I have a number of classes on serial communication between a normal computer and an Arduino. And what's really cool is basically using a USB connection, you can connect this to a normal computer, and the normal computer can actually send commands to the Arduino over that serial communication, and the Arduino can send information back to the computer based off of whatever values that it's seen. So I could do something like, let's say I have a login script. So let's say I have a relay connected to this that can turn a light on. So I could have a login script on a Windows computer, where when I log in, it fires off a script that, using serial communication, can then communicate with the Arduino and tell the Arduino to turn the light on. So when I log into my computer, I want these lights to turn on, I want this fan to turn on, and I want the radio to turn on, right? I connect all of those electronic devices to my Arduino using a USB connection. I then connect the Arduino to my computer. When I log into my computer, the login script fires. The login script sends serial commands to the Arduino, and the Arduino turns all of those things on. When I log off, there's a log off script. It sends a command to the Arduino, and all of those things get turned off. So that's an interesting thing to play around with. So basically, that's a way to give a normal computer GPIO pin access, which is fun. I don't know how useful it is really, but it's fun. Then you can also have wireless modules. So these are wireless modules that you can add to your Arduino projects. And basically with these, not using TCP/IP, just using analog wireless communication. I think these use 433 megahertz, I think they are. Basically, you can have different Arduino devices communicating with each other, right? So you can have the transmitter plugged into this Arduino device and the receiver plugged into this Arduino device. And if this Arduino device senses something, it can then send a command to this Arduino device. When this Arduino device receives the command, it can then do something, right? So if we have movement, let's say I have a motion sensor connected to this Arduino, the motion sensor gets triggered. Once the motion sensor gets triggered, it then sends communication using this Wi-Fi module. This Arduino receives that communication and then turns on, a buzzer, or turns on lights, or turns on something else. So you can use that for wireless communication that's not necessarily TCP/IP. And then you can also use that infrared access. So basically, just like you can turn on a television, or you can turn on other things using infrared, like a little infrared remote control like this. You can actually add infrared receivers to your Arduino projects and actually be able to control them, sending them commands using infrared. So that's a different way you can also communicate with the Arduino devices, and kind of like in ways that people might not be thinking about. Now, if you think about powering your Arduino device, it's relatively easy. So if you want to power it, basically there is a USB connection on here, and so anything you would normally plug a USB cable into, you just plug that USB cable into that, and then you can power your Arduino device. So you can power your Arduino device plugging it into a computer. As you'll notice, with this little remote control car that I created, I am actually powering this off the world famous IDE battery pack. I got these battery packs from IDE. I was a contractor for IDE for a little bit, and they gave me all these battery packs as like a promotional thing, and I have been using the hell out of these. But anyways, right, for this whole project, the Arduino, the motors, everything is actually just off of a stock standard promotional little USB battery pack. So that's one of the ways that you can power your Arduino devices. I like using the USB battery packs, kind of like a director's note here. One of the reasons that Silicon Dojo uses these USB battery packs rather than normal lithium-ion batteries or normal batteries is because these things have circuitry in them to protect them from shorts. So what a short is when positive and negative connect, and basically all the energy goes from positive to negative. At that point, essentially your battery can either melt or it can explode. If you have a lithium-ion battery and you have a short, the entire battery can go boom. Boom. Again, what is one of the #1 rules about Silicon Dojo? I don't want liability for crap, right? You are not allowed to drink beer in Silicon Dojo because I don't want the liability for alcohol on premises. There's a whole bunch of things you can't do with Silicon Dojo because I don't want the liability. I sure as hell don't want the liability of lithium-ion batteries exploding on students. So one of the reasons we use these USB battery packs for these electronic projects is they have little circuitry in there. When they detect a short, basically it just fails out and the battery stops working. So basically it stops working and it won't start working again until you unplug the short and you let it set for about 30 seconds and then everything resets in there. So it has a short protection. So again, if you're going to be doing Silicon Dojo in your world, use the USB battery packs. The lithium ion batteries are really cool. Like just stock standard lithium ion batteries, they're going to be a lot more lightweight. You're probably going to get a lot more power out of them, the whole 9 yards. But they might go boom. They might go boom. I don't want it to go boom. I don't want it to go boom. I'll take a little bit. I will take the extra weight and the extra expense of a USB battery pack. But that's one way you can connect it. Also, you'll notice it does have a barrel connector on here, so you can use a normal power connector from a wall, just a little 9 or 12 volt power connector. You can connect that to the Arduino, and that will power your project. Or you can actually connect a 9 volt battery to an Arduino, or you can connect multiple AA batteries to come up with like 12 volts and connect that kind of battery pack to an Arduino. I will tell you, don't do that though. Unless you got a lot of money, unless you have money to burn, do not connect 9 volt batteries to your Arduino project. Arduinos eat 9 volt batteries. Because here's the thing, right? If I run through all of the power in this little USB battery pack, I just plug it back in, an hour, I have the battery pack again. 9 volt batteries, you plug into your Arduino project, if you're doing something like a vehicle, it will eat through all of the electricity in that little battery in like 5 minutes, and then it's trashed. It gets very expensive very quick. So can you power these things off of 9 volt batteries? Yes. Should you? No. Unless you got a lot of money. Let's see here. And then we have the Arduino IDE. So I'm about to show you the Arduino IDE so you understand a little bit better. The big thing, big question people ask is what language is Arduino? What language do you code Arduino in? Apparently it's C++. Man. It's kind of like when you're learning, there's all this stuff you do in order to code for Arduino, and you just learn it. Again, it looks C-ish. Apparently it's C++. So if you know C++, it should be pretty easy. If you know C, it should be pretty easy. Honestly, if you know how to code, it should be pretty easy. There's some like syntax things in there you have to understand. It's pretty simple code, but again, everybody always wants to know, what language is it? Apparently, I'm told it's C++. So with that, let's go and actually take a look at the Arduino IDE. Okay, so let me see. Let me see how I can do this, so I can actually show you folks what's going on, and I can see it myself. Okay, let's expand this thing out so you should be able to see what's going on. Okay, so this is the Arduino IDE. So this is free from Arduino. If you actually go to the Arduino website, you can go to, it's arduino.cc. So it's arduino.cc. You go to software, click on software. When you click on software, it will give you the downloads. So you can download for Windows, you can download for Linux, or you can download for Mac OS. So you click on that, it will ask you whether or not you want to give them any additional money. You say no, of course. So sad, but true. And then you download the Arduino IDE. There's no cost to it. Some people ask, can you use something else to code for Arduino? And I guess technically, there are other ways to code for Arduino other than the Arduino IDE. And if you want to figure that out, go for it. I've heard people use VS Code. I've heard that. I've been informed that. I actually haven't seen it yet. And anyways, for when I'm doing these projects, I don't really care that much. So anyways, when you open it up, basically this is called a sketch. So in the Arduino world, this is what's called a sketch, and let's go up and take a look at some things. So we click up here on Arduino. The first thing that you want to take a look at is preferences. So preferences gives you some things that are valuable and some things that are not. So add editor font size. All right, so you probably normally want this at 12. I'm trying to show you folks what's going on, so I have it at 24. That's there. One of the big things is display line numbers. It's a pain if you don't do that, right? So when you're trying to figure out how the code works and you don't have any line numbers, that is a difficult thing. So if you're new to coding, always make sure you got those line numbers going on. So I think by default that's off, so you can click on that. Verify code after upload, so that basically when you're uploading the code to your Arduino, it verifies that it's actually going to work properly. And then one of the valuable things here is enable code folding. So what code folding is
See, I don't know if you can see, but there's these little negative marks over here. Basically what you're able to do is you're able to close entire functions. So if you have a lot of code, it's kind of hard to go through all of that code if it's all open. So you can click on the little plus or minus sign beside each one of the functions and basically collapse it or open it up. So that can be a useful thing there. And then we just click OK, right? So again, with code folding, so you have the serial begin, that's that void setup. I can just click on this and it goes away. The void loop. Right, so imagine if I have a lot of stuff and I'm trying to sort through and figure out where my problem is. And then I can just open up, be like, okay, I think the problem is in the setup, and then, okay, I need to change the value here for the baud, that type of thing. If we go up and we take a look at file, one of the valuable things that the resources that they give you is these examples. So especially when you're new, when you're playing around, one of the easiest things is just grab an example that they have and then just modify that, right? So if we go over here, they have basics, they have digital, so doing buttons and things, analog communication, USB, all kinds of weird stuff. Liquid crystal display, robot control. Right, so if I go here to basics and I click on blink. So this is a sketch that does blink. Let's open this up all the way. Basically, all this sketch does is it makes a little LED. There's an LED that's actually built onto the board, and it makes it blink. Complicated, right? But it gives you all the code here, right? So there's no setup or whatever. Here's the void, pin mode, the built-in LED. You set it to output. Then you digital write to the LED built in to high, so you turn it on. Then you delay for 1 second. Then you digital write to the LED built in low, which turns it off. Then you delay 1 second. And then you loop, 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 right? And so that's the basic example that they have here. But if you go through, you can see they have a lot of different examples, and depending on what you're doing, some of them can be more or less useful. So servos. So a servo motor is a motor that you can actually put to a specific position. That can be useful. So if you want to create like a steering wheel for a car, you might use a servo motor to turn to a specific position. If you were doing like a temperature gauge or maybe a clock face, you might use a servo motor. But anyway, so they have an option here, or they have an example here, for sweep or knob. So you can open that up. Oops. Of course, it opened up on my other screen for some reason. It's just being annoying. And then here, if we open this up, here's where we include a library. So a servo motor is a digital device. So we include the servo library. We then create basically a resource for that servo. We create an initial position. And then basically this is code for having the servo move from position to position. So this is the sweep. So basically with this, it'll sweep through all of the positions. So if you were trying to create a project with a servo motor on it, you could open up this particular example. You could say, okay, I need to include the servo library. Okay, this is how I create the servo resource. Okay, this is how I set the servo to a specific position. So my servo.write, and then this is the value for what position it goes to. So if I didn't want to sweep, I just wanted to have it go to like 90 degrees, then I'll go, oh, my servo.write 90. That should get it to 90 degrees. So these examples just can be very useful for going through and actually seeing working code and then figuring out how you can hack that working code to do what it is that you need it to do. Let's see, past that, you got the sketchbook, the example, save, all that, edit, all that kind of stuff going on, sketch. You verify, so the verify compile, so before you upload it, you can just basically verify the code, make sure it works, make sure you didn't miss anything in the code. I have some other stuff there. Then we go to tools. So auto format is useful. Auto format is wonderful for coders like me. All right. I'm an ugly coder. I'm an ugly, ugly, ugly coder. As I say, I am an IT professional. And IT professionals literally have duct tape in our toolkit. Duct tape is considered a fine way to solve a problem. That doesn't make the nicest code. So, if you're doing Arduino, basically if you're going to be writing Arduino code that anybody else is going to be seeing, you might want to use the whole auto format thing, right? So if I go here and I tab this out, and let's say I put this in, I do what an Eli does. If you go here to Tools to Auto Format, it'll go through and it formats it a lot nicer for you. Maybe not quite perfect, but a lot nicer, right? So if I did that, and I did that, and then I did that. Right, that looks like how like Eli would code. And I go tools, auto format, boop. It puts it all nice into a nice format. Now it is important to understand Arduino is not like Python, so Python, all the indents and all that kind of stuff actually matters. In the Arduino world, that kind of indentation does not matter. Basically, you're using the delimiters are semicolons. So you need the semicolons in order to delimit, but you can have it basically in one big ass line. So you don't have to have the tabs and all that in order for the code to work. But if anybody else is going to be looking at your code, I'm just saying click that auto format button. It's kind of like, spell check on a word processor, right? Your report still says the same stuff even if all the words are misspelled. But if you're going to be handing that in for credit in school, run a spell check over it and you'll probably get a lot better grade. Same is true here. If you're going to be publishing your code, or if you're going to be showing other people code, just hit that auto format button. You'll be happy for it. Then past that, we can go through manage libraries. So basically with this, these are the libraries that are available to you if you're going to be connecting the digital devices. So again, when I talk about that DHT11 temperature sensor, when I talk about the GPS unit, whatever device you're connecting that's a digital device, in order to control the digital device, you need a library. Now, for whatever reason, I don't understand in the modern world. In the modern world, we have terabytes of storage on our computers, and yet they don't just download all the libraries for you. So basically, one of the problems you might run into is a library that you need for whatever you're using. Let's say like this, like the tiny GPS. You might actually have to go in and actually install that. Hold on one second. Let me make sure what Wi-Fi I'm connected to. Okay, so I'm connected to that. And so, I don't know. So if I'm trying to find GPS, and I do that, so this gives me the different GPS libraries. Arduino MKR GPS allows you to read location from the GPS on your GPS shield. Arduino library for interfacing any GPS, GLONASS, Galileo, the whole 9 yards. And what you'll see is that it has the install button. So whatever library you're looking for, you can just go through here. You can try to figure out what library it is that you actually need. And again, for some of these things, there's a lot of libraries. Again, one of the issues, I mean, it's not really that bad, but one of the problems you can run into with open source projects is that since anybody can code for the open source projects, many times you get a lot of options. You get so many options. And so figuring out which thing, like a library you need to use, can be a pain in the butt. So this is sometimes where you just need to do research, do some Googling. But you can go through here and then you can figure out, whichever GPS one you want to use. Yeah, tiny GPS. So I found, just for me, tiny GPS worked pretty well. So I could just simply go over here, click the install button, and then that would install the tiny GPS library into my Arduino IDE, and then I can call that library when I'm going to be creating code. And so that's there in the library manager. Then past that, if we go up, take a look at the tools. We have serial monitor and serial plotter. I'll show you that in a second. Then we have the board, right? So this is important. I don't know if you can really see it on here. So it says board Arduino Uno. So all of these boards are different. All these boards are different. And so you need to select the proper board here in order to be able to actually upload the sketch onto your project, right? So I can go here, and if I go over, I look at Arduino AVR boards, and we can see all of these different boards. If I go down here to the Mega board, I've got the Wi-Fi Rev 2 and the Nano Every. I go here to the Minis, there's mini boards, ESP8266s, there's a crap ton of boards there too. And so the important thing is if you're trying to upload and it fails out, most of the time it's because you're using the wrong board. So like with me, when I'm building these projects, I swap between the Arduino Uno board and the Arduino Uno Wi-Fi a lot. Like I'm just picking and pulling depending on what I'm doing with a project. So a lot of times when I'm uploading, it'll fail because I'm using an Arduino Uno board and I have it set to Arduino Uno with Wi-Fi. Pretty simple, but it can still be a pain in the butt. The other thing you run into is port. So what port is your Arduino connected to? And then you have to select that to make sure that it's actually communicating. See, so now it's active. So with this, it theoretically says you can connect over the Bluetooth port. I don't know, it says you can connect with my AirPods.
I don't understand what that is. The main one is there's a USB modem. That's the one that you're going to want to connect to. So again, if you go to upload the code or communicate with your device in whatever way, and it's not working, a lot of times basically that port won't be set or it'll be wrong, and you go there and you click on it, and then it will fix it for you. And so that's the basics of the Arduino IDE. So this, like I say, this is the code that we actually have running on this little temperature project at the moment. Again, if the temperature value goes above 80, then the red light turns on. Come on. Oh, there we go. There you go. Red light turns on, and then when the value goes below 80, the green light turns on. Now, one of the things you can do is what's called the serial monitor. So you'll notice here that I have serial.print voltage, serial.print temperature C, serial.print temperature Fahrenheit. So you can print out to what's called the serial monitor to actually see the values that your Arduino project is dealing with. So if I go up here to Tools and I click on Serial Monitor, and that comes up on my other screen, of course it does. And so this should be showing me the temperature values. Hello. Oh, okay. Let me try to upload again. Let's see. Upload. So we're going to upload. So compiling Sketch. Sketch is uploading. Please don't fail. Please don't fail. Don't embarrass me. It's been a long day. It's been a hard week. Okay, programming not responding. Oh, you ever have one of those days? Never have one of those days. Okay, let's say Tools, Arduino Uno. Alright, so there's something going on. So let me unplug it. When in doubt, reboot. When in doubt, reboot. Let me plug it back in. Alright, so we've now plugged it back in. Okay, the green light is on. Okay. Now we're going to upload. Come on. Come on. Let's do your job. Okay, done uploading? Okay, it's done uploading. Tools, serial monitor. Oh, okay. Yeah, it works. Yeah. Anyway, so you can see it's 0.72 volts. So again, that's that voltage. When we're dealing with analog values, right? We get an electrical voltage in, and we have to read it. So we have 0.72 volts. 0.72 volts goes through the math, comes out to 21.78 degrees, goes through some more math, and comes out at 71.2 degrees Fahrenheit. If I put my finger on the thing, you'll notice down here it goes to 22 degrees, 72 degrees Fahrenheit, 25 degrees, 78 degrees Fahrenheit, 27, 80 degrees Fahrenheit, and the red light goes off, right? So this can be a very useful tool for you for troubleshooting. If for some reason you know something should be triggered based off of your sensor and it's not working properly, if you use a serial monitor here, you can see the values that it's reading, and then you can figure out what the problem is. A lot of times you'll run into that issue, especially with analog sensors. Like sometimes you'll blow out the analog sensor. Analog sensors are very fragile. One of the reasons they cost about 10 cents a piece, it's very easy to kill an analog temperature sensor. So one of the problems you might run into, right, is if you're processing and you're doing the if-else statements, and like you have some kind of max, like if it's above 120, right, it shouldn't be above 120 degrees Fahrenheit, then do something. Well, the problem is if your analog temperature sensor, if something's screwed up with it, the voltage coming through, there might be a short within the sensor itself. So the voltage coming through might be like 3, right? It says 0.75 here. You might be getting 3. Well, if 3 comes through and then it gets processed to the degrees in Celsius, then instead of being 24, it'll be like 90 degrees Celsius. It goes through the math on that, and then it comes out to like 400 degrees Fahrenheit, and then your system is failing, right? The problem isn't your code. The problem isn't your wiring. The problem isn't what you think it is. The problem is you blew out your temperature sensor. So using the serial monitor is a way of doing troubleshooting and making sure the values you're getting are the values you think you're getting can be incredibly useful. And so with that, I think that's actually the class. I do believe that is the class. Is there anything else? No, that's it. So that's basically just a brief introduction to what an Arduino is and how all of this kind of stuff works. Again, there are a lot of different Arduino boards out there. So there are the official Arduino boards. The official Arduino boards are built by the fine people in Italy, and it is wonderful Italian manufacturing. You will never hear me snark about the quality of genuine Arduino boards. They really are good, and again, for Silicon Dojo, I bought official Arduino boards because they just do what the hell they're supposed to do, and sometimes that's worth a couple of extra dollars, right? But there are a lot of different Arduino boards out there. There's the Arduino Uno, the Mega, wherever the hell it is, the Arduino Uno with Wi-Fi, right? These are all official Arduino boards, and there's probably 20 or 30 others. One of the issues that you're going to run into when you're doing your projects is just figuring out which one of these boards does exactly what you need to do. It is interesting, the boards are so different in some ways. Like, this is a Leonardo board, so this is a clone Leonardo board. But one of the cool things with a clone Leonardo board is this can actually send mouse and keyboard commands. If you really want to screw with your friends, basically with this, using its USB connector, since it has a different chip in it, has a different IC chip in it, it's actually able to send mouse and keyboard commands. And so instead of using that whole serial monitor thing I was talking about before, this could actually act as if it's a keyboard. Right, so like one of those ghost keyboards. You plug this into your friend's computer and you just add some code so that it like randomly starts typing letters or randomly starts plugging in keyboard commands, and you can have oh so much fun. But anyways, that's one of the weird things the Leonardo board does that the other boards don't do. So there's a whole bunch of different functionality with the boards. And then the thing to realize is, again, these are open source, so anybody can create their own clone boards. And so lots and lots of different companies do create their own clone boards. When you're dealing with clone boards, some clone boards come with extra components. Like that one I showed you for $7. It comes with an ESP8266. That is a Wi-Fi, TCP/IP Wi-Fi module built into it. So for $7, you get an Arduino board with a Wi-Fi module built into it. So that's an extra thing that one of the clone manufacturers added. So that's one of the values of dealing with clone manufacturers. Beyond that, though, you do have to think about the manufacturing quality. So this is DF Robots. This is a DF Robot clone board, and I have to genuinely say, DF Robot does a good job creating clone boards. I would probably trust DF Robot clone boards if they're a little bit less than Arduinos. On the other hand, I've got SainSmart. I would not buy SainSmart. Again, technically it all works right, but I don't know. As far as I can tell, in my less than humble opinion, the manufacturing quality on SainSmart boards isn't that great. Now again, it depends on what you're trying to do. If all you're trying to do is connect a relay and an analog temperature sensor, you're not going to be adding shields, you're not going to be doing other things, then having a lesser quality board might be absolutely fine. On the other hand, again, like in an educational environment, or if you're going to be selling these to businesses, right? If you're going to be selling these to businesses and you're giving them warranties and all that kind of stuff, you might want to go with a higher quality board just to make sure you don't have to send a technician out and fix stupid things that failed because the quality control wasn't so good, from the place that you bought the board from. So that's one of the things to think about. The other thing to think about too is that whole storage thing, again, that flash storage. Since clone boards can basically be built however the hell they want to be built, one of the issues you may run into is that the flash storage on clone boards may be different than what you're expecting. So a clone Leonardo board or a clone Leonardo board or a clone Uno board, this may actually have different storage on it than the stock standard. Now to be fair, it may not be a bad thing. You actually may get more storage on a clone board than you get on a traditional Uno board. But again, one of the big things in the technology world is replicatability. Once you design something, can you deploy it relatively easily? So if you create a project and you use a clone board for doing the prototyping, and then you plan to deploy it to an actual Arduino board or to a different clone board, you may run into an issue is when you start uploading the sketches, they start failing out because the clone board you used had more storage than the clone board you're trying to upload to. And then fun ensues. So that's a lot of interesting things to be thinking about with the Arduino. Again, if you go to EliTheComputerGuy.com, I have a crap ton of classes. I have like 40 or 50 classes and a whole bunch of different stuff that you can do with Arduinos. I think Arduinos are really, really awesome and cool. I think Arduinos are one of the perfect places to start for people learning how to do technology, because again, you get to learn how to do coding, you get to learn how to do input-outputs, you learn how to do networking, you learn how to do a lot of things without having to deal with Microsoft. Come on now. It's a new technician. You got this nice little noob in front of you. Keep them away from Microsoft as long as possible, right? At least that's what my thought is. So anyways, that is the class for today. And if you're going to steal this class and try to use it, for your students, just ask yourself if your students actually care. Again, doing Silicon Dojo, a lot of what I'm doing here, this is in the real world. I'm throwing stuff out there, and some things people are more interested in, and some things people are less interested in. And sadly, Arduinos seem to be one of those things people don't have a whole lot of interest in, even though I think they're really awesome. So if you're going to do a class, just talk to your people and see whether or not they really care. They might be far more interested in some stupid-ass cybersecurity thing that they're never actually going to use in the real world because it's called cybersecurity, and that sounds cool. So, something to think about. Again, with these seminars, I will put the presentation onto silicondojo.com. You can take the presentation, you can take all the information that I've given, you can modify, edit it, do whatever for your particular environment, and then you can teach the class based off of what you think is most appropriate. Again, Silicon Dojo, basically the concept here is that we are free to the end user technology education. So when people come here, when they actually do come here, they do come here. We've had a lot of people come, just not last night. Basically, they get free education. We separate the payment from the education, so the people that can pay, the people that are willing to pay, they do pay. The people that can't pay or are unwilling for whatever reason don't pay, and that's how we try to create a good, educational environment. We'll see how that works out at the end of the day. So if you value what I'm doing, if you value what I am trying to do here, if I have given you value, please think about clicking on the donor box link, wherever that is, on whatever site you're looking at this on, and throwing a couple of dollars in there. It really, really does help. If everybody throws in, a couple of dollars, a lot of people throwing in a couple of dollars turns into some real money, and then that can pay for Silicon Dojo and all the things I can do. Again, the whole argument about $15 an hour minimum wage. For me to be able to pay a $15 an hour minimum wage, I need to be bringing in more than $15 an hour to pay people that type of wage. So it's just one of those capitalist things some people don't seem to grasp. So anyways, as always, I enjoyed teaching this class. I look forward to seeing you again, and hopefully sometime here in Asheville, North Carolina.